we will continue on, and unfortunately, we can't, answer every question here. But people are asking about the apps. There's a bunch of radar apps out there. If you go to your Apple Store or Google Store, there's plenty out there that many use. There's a lot of websites out there as well. For looking at model data, there are places like, College DuPage. A lot of meteorology schools have websites. There are people have mentioned Pivotal Weather. There's also other private sector companies that provide, you can get weather data as well, model data. It just kind of depends. All the model data is the same, whether you look at it on Pivotal Weather or College DuPage. It just depends on your user interface and what you want to look at. And yes, like I mentioned, yes, the slides, we can't share the slides because these pictures are copyrighted, so people have given us permission to essentially use that. But if you want to watch our spotter training, we have recordings on our YouTube. So if you go to NWS Norman on YouTube, you can watch recordings of our spotter training. But yeah, we can't share the slides because they are there's copyrighted material on here where people only gave us permission to use them for our spotter training. So, all right. Let us talk about tornadoes now. The tornado definition is basically this: a rapidly rotating column of air extending vertically from the surface to the base of a cumuliform cloud. In other words, a thunderstorm cloud, often with near-surface circulating debris or dust when over land, or spray rain when over water. Although its presence is not required, a funnel cloud is often visible and may partly or fully extend from the cloud base to the ground. Tornadoes that occur over water are classified as water spouts. And then land spouts are actually a subset of tornadoes that occur independent of a parent mesocyclone, and we'll talk about that later on. So as a storm spotter, it's important to understand the storm evolution that leads to the formation of a tornado, or in other words, tornadogenesis. So let's go through the stages for a supercell tornado, starting with the developing stage. We want to first note that tornado circulations can develop from either the ground upward or from the middle and low levels downward. There's still a lot of ongoing research on this topic. But in the developing stage, the RFD and precipitation southwest of the wall cloud may signal processes that help establish a tornado, such as a developing clear slot. Some tornadic circulations start in the low levels near the cloud base. So if you see rapid accelerations, in other words, increasing and rising inflow of cloud material, sometimes we call it rising scud, into an area of tightening rotation beneath the wall cloud, a tornado may be developing soon. The mature stage is potentially the strongest and most dangerous stage of the tornado's lifetime. In this stage, the funnel often has a near vertical orientation. Note that the visible funnel may not extend all the way to the ground or may become hidden inside the wrapping precipitation. Often the RFD wraps around south and east of the wall cloud, gradually cutting off the original inflow air. The rain-free base may take on kind of a horseshoe-shaped appearance. The tornado wall cloud may be found at the north end of this structure. In the dissipating stage, the RFD wraps around the tornado. As a result, the tornado is separating from the warm, buoyant air that it needs for survival. As this happens, usually the tornado shrinks, kind of tilts, and sort of takes on a contorted, sometimes snake-like appearance before dissipating. Sometimes this is referred to the rope stage. It is important to note that although the tornado is not as large as it was in the mature stage, it can still be dangerous, and sometimes it can be in its most violent state during this part of its cycle. Again, we have something called cyclic supercells, where inflow is refocused a few miles east of the dissipating tornado, and you may have a new mesocyclone and wall cloud that'll form. And this new mesocyclone and wall cloud will usually become the dominant part of the storm, and a new tornado may form. And this old tornado may have what we call deviant motion. A deviant tornado is any tornado perceived to move at a different speed or direction than its parent storm. Here's an example of a cyclic supercell in Stockton, Kansas. You'll notice there's an old tornado in clear slot in the left foreground, and then a new tornado in the right background. So this is why it's important to be situationally aware. You may think, oh, I see the tornado, but there could be another tornado developing right on top of you. So you got to always be aware of what's happening. Here's another example of a cyclic supercell in Zurich, Kansas. Again, note that there's simultaneous tornadoes from two different mesocyclones. To the left, there's a fully condensed late-stage tornado from an older mesocyclone. To the right, there's a tornado without condensation in the debris cloud, which is becoming better organized in the newer mesocyclones. You see, both of them have tornadoes ongoing, both mesocyclones. So sometimes the atmosphere does weird things, and you can have some chaotic things where you have simultaneous tornadoes occurring at the same time. Just keep that in mind. You know, you don't have to have one tornado completely dissipated to get another tornado ongoing. And this is really important when it comes to safety. And bringing it back to safety, again, storm spotting, we always emphasize safety. And it's important to know that tornadoes don't always follow the storm motion. They can deviate to the right or to the left. And this left deviation is usually when the tornado is about to dissipate. This is sometimes known as the occlusion stage. And deviation does not tell you if the tornado is becoming weaker or stronger. Leftward deviation can be quite significant and chaotic. We can even have loops occur. This is why we kind of bring it back to safety. The safest place to storm spot is to the south or southeast of the tornado. If you're north or northeast of the tornado, you will be in danger if the tornado deviates to the left. So you don't want to be in that red X, because if that tornado turns to the left, it's not going to be good for you. You want to be in the green area, essentially. If you're storm spotting in your vehicle, you want to be in that green X. Because if it deviates to the left and you're in that red X, the tornado would go right on top of you. So why do tornadoes deviate? Well, during the occlusion process, the tornado detaches from the parent updraft, and the tornado gets left behind and moves with the low-level flow. As I mentioned earlier, in our part of the world, low-level flow is usually from the south or southeast. So winds are coming from the south or southeast. Because of that, the tornado moves to the north or northwest as it occludes. So the tornado is essentially tugged or pulled by both the low-level winds and the parent storm. When we have the occlusion, there's a separation between the parent storm winds and the low-level winds. So the winds aloft from the low-level winds. And then what happens is essentially the tornado gets left behind and gets pulled by the low-level winds while the storm continues with the upper-level winds. Usually the tornado will go to the north or northwest, while the supercell goes to the east or northeast. And we saw that on April 19th, 2023, here in central Oklahoma, where we had a cyclic supercells where we had tornadoes that turned to the left as new tornadoes developed. I'll just play the same animation here. This is a storm following radar animation. And it might probably look a little wonky on there, so it may not look too well on the online just because of people's internet and just bandwidth, but essentially you had a series of circulations that developed And you had a lot of weird things happen where you had a cyclic supercell, where you had tornadoes turning to the left. And I'll show you the final pass of the tornadoes. It'll be a little bit clearer on that image. So these are all the tornadoes that happened on April 19th of last year, so about a year ago. And you'll notice a lot of these tornadoes had some interesting motion. Like you'll notice that tornado to the west near Cole, it was moving to the northeast, but then it turned to the left and almost moved due north. You see another tornado in eastern Cleveland County where it actually dissipated and then redeveloped in western Pottawatomie County, dissipated again, redeveloped near Pink, Oklahoma, and then turned to the northwest and came back into Cleveland County. You had another tornadic storm that went through Shawnee that turned to the left and moved due north. I'm showing you this graphic to show you that tornadoes a lot of times, most of the time, don't follow straight lines. And if you're storm spotting, be aware of that, because you could get in trouble if a tornado turns to the left. And usually when it turns to the left, you can have some chaotic stuff happen. You notice there's not as much chaotic on the right side of these paths. Most of the chaotic stuff happens on the left side during the occlusion process. And these tornado paths, and they're color-coded by EF intensity. So the orange, like the Cole tornado, was an EF3 tornado. The Shawnee tornado was an EF2 tornado. And you had one also from Washington to Slaughterville, which was an F0 tornado. You can see that just had a lot of chaotic motion, and you can tell these are not straight line tornadoes. They had a lot of curved paths, and you can't assume they're going to go straight. If you do, you're going to get in trouble while storm spotting. So put this in here to emphasize the importance in storm spotter safety. You always want to be the south or southeast of a tornado, because you'll notice even when they turn a little bit to the right, usually they're not as significant as when they turn to the left. Again, just reiterating, rightward deviation is not as chaotic as that leftward deviation. Again, you don't want to be on that red X. You want to be on that green X, because that is a dangerous part to be in. If you're from western North Texas near Vernon, you may remember the Lockett tornado. This was the same day as the Seminole tornado we had back on May 4th, 2022. This one also, generally had a straight path, but then it turned to the left and hit Lockett. And you had some damage in Lockett. And you had a storm chaser tour van that was hit by a tornado in Lockett, because likely they were not anticipating that leftward turn. Back on the Seminole day, on the same day on May 2022, we had a tornado that actually did a loop near Earlsboro, Oklahoma. And then it dissipated, and the second tornado developed near Highway 9. This tornado basically tracked along Highway 9 before it dissipated northwest of Seminole. Again, tornadoes do crazy things sometimes, and this is really important when it comes to storm spotter safety. The Newcastle, Oklahoma City Moore tornado from 2013. It did a loop near the 7-Eleven, and it didn't even dissipate during that loop. That's actually known as a failed occlusion. So usually when a tornado turns to the left, eventually it dissipates during the occlusion process. But once in a while, you may have a failed occlusion. Well, it does that occlusion and even does a loop in this case, and then continues on. It doesn't fully dissipate. You need to keep that in mind. You may think, oh, this tornado is about to dissipate. The most likely scenario, yes, it will dissipate, but you got to be prepared for the case where it doesn't dissipate, does a loop, and continues moving to the east. Showing you all these examples just to show you things can be really crazy when it comes to tornado paths. These tornado paths can be completely independent of the supercell path. The supercell is still moving to the east, but that tornadic circulation may do a loop within that supercell. Again, just re-emphasizing, tornadoes do not always follow the storm motion. That leftward deviation can be quite chaotic and significant. All right. One other way we get tornadoes in our part of the world is QLCS tornadoes. We discussed that supercells. Another type of storm is QLCSs. So what is QLCSs? Well, this stands for quasi-linear convective system. Essentially, squall lines, bow echoes, those all are QLCSs. It's basically a line of thunderstorms. We've had several in our area. Some recent events. May 2nd, 2018, the F1 tornado touches down in Norman. October 9th, 2018, we had 8 tornadoes that touched down in central Oklahoma. May 25th, 2019, the room looked like a bomb. 2 killed, dozens injured in a tornado that hit El Reno. The reason I'm showing you these articles is I want you to realize that yes, QLCS tornadoes tend to be weaker, but that's not always the case. You still want to take QLCS tornadoes seriously because they can be significant. And in this case with El Reno, they could even cause fatalities, unfortunately. So QLCS tornadoes should not still be taken lightly, even though they tend to be more transient, shorter lived, they can still be destructive. They have strengths comparable to mesocyclones associated with supercells, but they are different than supercells. Don't expect them to be visually the same. They often look visually different. You don't expect to see the striations, curved inflow bands, and many times tornadoes will be rain-wrapped in these QLCS events because they're within lines of storms. Basically, don't expect that. Now, not all mesovortices within QLCSs produce tornadoes similar to supercells. Most of them don't, but the stronger, longer-lived, and deeper ones are more likely to produce tornadoes. Like we had on May 25th, 2019 in El Reno. Again, you want to take them seriously because they can be significant. This one, a few years ago, was rated EF3. It was only on the ground for 4 minutes and had a path length of only 2.2 miles, and it was only 75 yards wide. Even though it was so small and on the ground for such a short period of time, it still resulted in 2 fatalities, 19 injuries because it hit the wrong spot. A lot of times these QLCS tornadoes, because they are so short-lived, they may not hit anything significant. In this case, it hit, unfortunately, a bad location near a hotel, essentially a hotel. If it hit a mile or 2 south, it may have been more in an open field, but here it hit that intersection of Highway 81 and I-40 on the south side of El Reno. And here's some pictures. Again, so yes, though it's rare, QLCS tornadoes can be significant and can be deadly, but they will also look different than supercells, and visually you will not see this. We had a QLCS event that hit central Oklahoma last year, February 26, 2023. Again, the animation may look a little, hard to see maybe on the web, may look a little stuttered, but this was a line of thunderstorms that moved through central Oklahoma, and this produced a QLCS tornado that actually hit Norman, actually hit really close to the weather center. Here's a close-up view. This moved through Norman and got very close to our office building. As a matter of fact, people at our office actually heard their ears pop. It actually moved within a mile or so from our forecast office in Norman, and we actually measured a pressure drop captured by the Oklahoma Mesonet station located near our building. All right, finally, we'll talk about land spout tornadoes. These occur from the stretching of environmental vorticity along a cold front or boundary. They occur due to stretching of environmental vorticity along a front or boundary and are normally associated with higher based storms. The land spout was named because it looks like a weak Florida Keys water spout over land. Now, these tend to not have the risk of being as intense. Like, you're less likely to see like a greater than an EF1 from a land spout. I'm not going to say it's impossible, but it's less likely. You know, it'd be more likely an EF0 or EF1 type of tornado with a land spout. You still need to take them seriously because, you know, that if that hits your house, that's still dangerous. Land spouts also tend to be more stationary because they are located near a front, usually a lot of times a stationary cold front. So they tend to not move a whole lot. And again, they look a little bit higher base. You can see from these pictures, they look higher base, and often, you know, people would kind of describe them as somewhat picturesque. You know, that image in the center, you know, a lot of people would say that looks like a very pretty picture, especially if it's an open field and not hitting anything. But, you know, you still need to take them seriously. We had an event in 2016 that affected areas near Chickasha. You had 3 little weak circulations, and you had 3 little land spouts in this particular case. Again, these tend to be on the weaker side, okay? You're less likely to not have significant damage from this, but it's not impossible. I do want to say, you know, storm spotting is hard, right? So here's a final quote from a paper from 2 meteorologists, Dr. Chuck Dawesville and Don Burgess. States the boundaries between events can become blurry when observed in the natural world. So, you know, scientists, we often try to put phenomena into discrete categories. And, you know, the public often want firm answers too. Was that a tornado or not? You know, in reality, you know, nature is often a continuous spectrum. You know, trying to storm spot in a continuous spectrum of hazards can be a challenge. You know, some events, tornadoes are obvious, right? In some cases, they are not as obvious. And usually the good news is the ones that are not obvious, the ones just like a brief little, you know, touchdown or a brief little dust cloud, or you can't tell, you got to kind of squint to see if there's a tornado. The good news, a lot of times when we're not sure, usually those are the weaker ones and the lower end ones, the EF zeros or the EF unknowns, you know. So the good news is the ones that we can't tell, you know, that's good a lot of times that we can't tell or we're not confident if it was a tornado or not. In that case, I think that's okay because that means it was a weak thing that didn't really cause much damage. The ones that are the big, obvious tornadoes, obviously the May 3rds, the May 20th, the Seminole tornado, where it's obvious it was a tornado, those are the ones, you know, are more likely to be the ones that cause more significant damage. I want to end with this important point. You know, no report, data, video, or image is worth your life, right? That's the bottom line. You know, sometimes people may try to risk their life to take a cool image or go through a flooded road to continue storm spotting. That's not worth it, right? You don't want to lose your life because of that. So everything I told you here, the number one thing I would want you to take back is safety. Take into account, remember, storm motion can be erratic, tornado motion can be even more erratic. No report, data, or video is worth your life. If you're storm spotting in your vehicle, never do it solo because you can't really navigate while looking out your window, while making sure nothing is developing on top of you. If you're storm spotting at night, that's even more dangerous. You know, that's strongly discouraged unless you really know what you're doing. Have a constant, you know, radar app, and you have a bunch of people that are helping you because nighttime spotting is even more dangerous because a lot of times you got to depend on, you know, lightning to see anything. Bottom line is you just want to take it safe out there. With that, that will be the end of our spotter training. We'll be on for a few minutes for any last minute questions. Again, we can't answer every question here, but I will say, if you want to, you're waiting for that certificate, give it about a week. We're going to send it to the email you registered. It'll be a blank certificate. So again, it'll be a blank certificate that you'll get via email. You can print it out. And if you have multiple people there in your audience, that's great. You can just print out multiple copies, and write individual's name on there. We don't require, for NWS Norman, we don't have spotter numbers. We don't require you to go through training to get a report. We'll take reports from anyone. A report or spotter training is supposed to help educate and make you better spotters, and hopefully also give you an understanding of severe weather, but it's not a requirement for us to go through spotter training and give us a report. So there's no, official, spotter number or something that we'll, need from you. We'll take your reports, just give us that call. Again, if you want to revisit this information, we can't email the slides, but go to our YouTube, NWS Norman. There's both the basic and advanced spotter training on our YouTube page. You can rewatch. And let me see what we have on the question front here.